Hello, and welcome back to Learning with Lee. In today's episode, we're going to discuss how virtual functions work. Virtual functions, as you might remember, happen to be things such as getName within weapon as well as within its parent class, item. And what it allows you to do is allows for something that is treated as an item to have specific functionality that would only normally be found in those children classes, even though it's considered an item at that time of its use. So, in this case here, we have a weapon for the type of object that actually is in memory, but we're treating it as its parent item, which is effectively a smaller object, but both of them have the virtual function getName. And what then is happening is that when we end up calling getName here, it is smart enough in order to select the one that is created in weapon, not the one that's in item. And this is what we're going to be discussing, and the way in which this is implemented is via what is known as a v-table, or virtual table, or virtual function table, and there's a few other names for it. But in general, you're just going to see v-table be the one that is used. So let's take a look at these as our example. So in here we have our two primary classes that we're going to take a look at right now. And what happens is that when the compiler gets to them, for every virtual function in them, it creates an entry into a static v-table. And it creates one of these v-tables for basically each one of these. So item gets its own v-table. So I'll just call it IVT to represent that it's the item's v-table. And within it, it has an entry for getName, which I'm just going to abbreviate GN for now. And what this then does is it then points back to wherever this happens to reside in memory. So basically it's a function pointer. And this table is just a set of function pointers. And then what ends up happening is that for weapon in its v-table, over here, it's also going to have one for getName, and that one then is going to point to its version. And this, in the most loose sense, is how it's implemented. So what it is you have these tables of pointers that point back to basically wherever in memory you're using. It's slightly less efficient because, well, then if you didn't have this at all and you weren't using virtuals, and that's because of a couple things. The first thing is that within any class that has a virtual function in it, and as a result we'll have a corresponding v-table for it, because these v-tables aren't actually created if it doesn't have any virtual functions in there. So if all it has is getName, then it doesn't need to have a v-table for it. However, in this case here, item has a virtual, so it would have this. Alternatively, in case, say, I didn't have that virtual there, and all I had was a function foo that was not virtual, it would not be creating this v-table for it, though item would have its v-table created that references back to this getName here. So let's say that instead, though, within here, I had virtual foo, and I did not have, so we'll just go with vfoo for now to represent that, and I did not have getName in here. What would then happen is that I'd have a second entry over here for foo, and that entry would point back to the version in here. Even if it's not something that item has, this might be something that's brand new that's virtual. I want things such as, in case you remember over here, we had things like melee weapon, as well as then there was ranged weapon for different varieties of weapons that you might have in an RPG. That happens to be used in order to, and it's used by those children classes. It's designed to be overridden in those, not necessarily something that should be used within weapon or item. However then, it still is going to have this entry here for getName, and it's going to point back up to its parent's one. And basically the way in which this works in memory is that when you try to call something that's on here, and this is where it gets a bit less efficient than if you just had a function in here where it can basically go, okay, I know where that is in memory, I just need to go to that spot in memory. What it has to actually do first is basically what you have also in both item and weapon, and this is hidden away from you, is you effectively have some little pointer here, and we just call it a v-pointer for now. And what it's a pointer to where your v-table is in memory, and it's hidden from you. It's not really something that you ever need to know about outside of the general theory of it. So what you do is when you have to use a virtual function, it looks it up in the vtable, so it goes to the vtable, and then basically each of these has an effective offset with it, so it goes to the vtable plus some offset. Think about like an array. In case you remember our example of arrays, where basically we had some little thing over here with a whole bunch of different entries in it, in which we could go, okay, here's 0, here's 1. You can think about it in a similar sort of manner for this, in that I know how far down in my virtual table this is, so all I need is a pointer to the beginning of it, and then go with some offset. So I can basically go, okay, I need to go to, initially it would be this address, plus some amount to get to the correct function within there, correct method within there. And as a result, what I then do is I have to then go, okay, where is this then in memory? Then head off to wherever that is in memory. So basically, if we treat this as our entire thing of memory, really compact, basically initially we would start from some spot where we're calling getName. So we just basically treat this as our start. It calls in to wherever the vtable is. So here's our little virtual table. And then this is going to basically return us a pointer to where we need to go to. And then from there, so basically here's step 0, here's step 1. And from there, we're going to jump to wherever that is, and then we're going to start executing on our function, and I'll just call it for now foo, since we already have that one defined down there. And foo happens to then be used in order to basically execute as normal. It's a normal execution of a function at that point. It just that we have this extra bit of indirection here of having to go and retrieve the information from the vtable. Normally, we're able to just go from here down to here, and that's our only step. So it adds in these 2 steps right here beyond your usual use of a function. Now, you might be wondering why I'm showing you all of this when really, as I said, this isn't important to know aside from the theory point of it. And that's because this really is something that you'll commonly see on interview questions, on different things that people, when you're looking for a job, will ask you or want you to know about is what's the vtable. And that's because that's how polymorphism and, to a certain extent, inheritance happens to be implemented behind the scenes. It's not a big deal. Anyone who really, let's put it this way, unless you're in an absurdly high-performance situation, this extra couple of steps here isn't going to matter whatsoever. It's going to give you a little bit of a performance hit, but you're never going to actually notice it. So overall, it's really nice, really useful, fairly simple and elegant solution. Couple things to note about it. There's only one of these vtables created for a given class that has these. So the more times you instantiate your objects, the only additional things that each of those objects have are v pointers. So basically each instance of an item will have a v pointer to the item vtable, or in case it's a weapon, it will have one to the weapon vtable. And as a result, basically what it is that it's a little bit larger on each of those instances. However, it avoids any of the craziness that might happen in case it tried to, say, copy around the function implementations with each one of these. So that's one of the nice things. You don't have to worry about anything like that. It allows you to have this nice bit for inheritance here. And it's overall not too much overhead for it. So, if you want to, I would recommend spending some time looking around the internet at different examples of how the vtable works, as there are plenty of different documents and people's blog articles and the like discussing how the vtable works. As I said, this is a fairly high level and quick overview of it, and realistically it's probably good enough in case you were to explain it in this manner in a job interview. However, at the same time, it's a matter of you might want to see a few more things just to make certain that you can begin to understand really how it ends up being implemented behind the scenes. And with that, I'm going to thank you very much for watching. Have a wonderful day.